All right. Hello, everyone. Thank you for joining the webinar today. Just a couple of things up top. We are recording this session, so we will be able to make the slides and recording available to you later. There is a Q&A box for questions that may come up as you go. We'll have some time at the end for some answers. And without further ado, we'll just get started. So I'll introduce our first speaker, Tom Chavez from SOASTA.
Max. Hello, everyone. Thank you for joining us today on this webinar on continuous performance testing and continuous delivery with Jenkins. I am Tom Chavez, and I'm Product Marketing Manager here at SOASTA. And with me in the webinar today is Brian Dawson, who is Practice Manager for CloudBees. Brian, want to say hello? I think Brian's muted. All right. Well,
hello. Yep, I just had to come off of mute, Tom. Hello. Thanks for introducing me.
Sure. All right. So we're going to do, we're each going to talk to you about our companies and the products and offerings that we have and how they complement together in this CI/CD space. And we'll do a little bit of a demonstration at the end. And we'll say, as we said, we'll have some time for questions and answers. So let's go ahead and move forward. Great. So first is we have a poll question. We'd like to get a reading of the audience here who joined in to get an idea where you are in your use and moving to CI/CD. And so let's go ahead and open up this question. And if you should see a polling box up on the screen, there are 5 choices. Are you practicing CI/CD, practicing CD, continuous delivery, actually implementing it, deciding if it is a good option, or wondering what the heck is CI/CD. So we've got 30 seconds to answer the question. Go ahead and punch in your answer now, and we'll see where people are. Four seconds, and the poll is over. All right, so let's go ahead and see the results of that. All right. Now, I don't see the results on my screen, so let's see. Max, if that's something you see, if you want to read the results.
Sure, yeah. So we're looking at 33% practicing CI, 13% practicing CD, 47% implementing CI or CD, and 3% for both determining if it is, the right option and what is CI/CD.
That's great. All right, thanks. Thanks everyone for participating in the poll, and that's good to see that everybody is in the process of practicing it and implementing it. Now, what we're going to cover in this talk is how performance testing fits into your CI/CD process, and a little bit of how to build some tests and set up a test environment, how to connect those tests once you built them into your CI system, and specifically Jenkins, and how to manage these tests to a baseline so that you can make that as a part of your automation, and executing the tests in parallel with the Jenkins workflow engine. And then we'll go ahead and do a demonstration and cover Q&A. And as we said earlier, please submit your questions in the question box during the event, and we'll get to those toward the end, or even if we can answer some of them in the middle, we'll see if we'll watch the queue and see if we can bring some of those questions and answers up too. So why should we load test earlier? Well, there's lots of good reasons to be doing load testing earlier. And all you have to do is look at some of those fun websites that we've all visited before, like healthcare.gov, or maybe the Best Buy website last year during Christmas. This is a good time of year to be finding websites that fail during during the season of Christmas, because everybody's doing shopping. Yesterday was one of the biggest shopping days on the web, Singles Day. I didn't get to see whose sites might have failed horribly, but there was lots and lots of transactions going on yesterday. And the last thing you want to have happen is for your site, your application, to go down when your customers are. So it's really not a question of why we should load test earlier. The question is really, why didn't we load test earlier? So let's look at some of the reasons. Some of the reasons why: because it's hard. Some of the load testing tools and performance testing tools are still kind of first generation tools that are quite a bit hard to use. while you're building your application in Java or Angular, or JavaScript, or an advanced language, your testing tool is still back in the days of C or Visual Basic style. Maybe you also don't have a scalable test environment where you can run your tests, and it's hard for you to set that up after every code change. Maybe you don't have hardware for generating the load against your site. Also, it's just a different tool. It's different than your development tool, whether that's Eclipse or whatever advanced tool you're using. And of course, there's so many other tests to do. You've got your unit tests to build. You've got other functional tests to do. It's just a hard thing. Now, that's not enough reason. Some people also say, well, it takes too long. Running a large load test can take a really long time. If you're going to test against a large load, say even some retail customers of SOASTA test up to 1 million and beyond virtual users simultaneously. To set up a test like that, some people say it takes forever to set up those types of tests, or it takes so long to run that kind of a test, hours and hours. It's not fast to set up environments like that. Or you're dependent upon your IT team to give you some hardware in production or in pre-production or in the lab. So you're always waiting for other teams to give you things. And some people's excuse, which really isn't a good excuse, well, we're just too agile. We build things too quickly. We don't have time to test to that level. And we'll just push it out to production and bring it out of production if it fails. That's the wrong place to be doing your load testing, by giving it to your customers. That's not where you want to find your performance bottlenecks. And some teams, well, they've just never been told to be doing performance testing as a part of their CI system. They've never been given performance coverage requirements. You've got code coverage requirements. You know, your unit tests should be covering 100% of your code, and your functional tests, if you're lucky, should be covering some 70% of your code in automation. Many companies don't have a performance baseline for reference of your code. How fast is the right speed for a piece of code to run? And so if you don't know what your target is, you don't know whether you're making your target or not, and you just don't have a performance metric. But that's all old. Those are all bad reasons, because now you can do this as part of your CI process. So here's another poll question. Try and find out why you are or are not doing a load testing approach for your performance testing in your CI system. So we'll open up the poll and give people 30 seconds to answer. You can answer more than one, so maybe you find multiple reasons: your skills gaps, issues with the testing tools, lack of deriving from management, etc. So fill out a couple of options that apply to you. We've got 10 seconds or so, or 15 seconds or so left to answer, and let's see what the survey says. And Max, I'll again ask you to give us an idea what the results look like. All right, I think that poll is closed. How's it look?
We're looking at 26% skills gaps, 28% lack of test environments, 10% slow test developments, 30% test tools limitations, 8% third-party dependencies, 28% undefined performance requirements, 24% lack of management push, and 4% other.
So we've got some issues everywhere. Thanks, Max, for reading those out. So we've got people with issues all across here, whether it's developing the test or third parties or undefined requirements. So these are all reasons that some of them you can solve with getting great tools. Others, you can set up a goal in your company for defining your baseline and what your performance metrics will be. And in others, you can work with third parties to help you with the test environments and also in addressing skills gaps. Great, thanks for responding, everyone. Now, in the past, load testing has been an event that is usually pushed off. In an agile world, we're doing these quick iterations of our code, and we're being good developers and writing our unit tests. We do another iteration, and we'll do some unit tests, and our QA, somebody will be working with us to do some functional tests. Eventually, when we're getting close to a release or some some process will be doing regression testing. We got a regression test suite that hopefully is that none of the new code is affecting that. And then we'll get around to load and performance testing and then deploy the solution. And in fact, some people just go ahead and deploy the solution and, as I said, let their customers do the load and performance testing, and then they have the issues in production. What's the problems here are that there are high expectations that the tests will give you great results, but the time to run the test in this type of a model is just getting shorter and shorter. If you're trying to set your application out in time for the holidays, well, Black Friday is always going to be on Black Friday. You can't tell the world that you need an extra week to get your application out. Also with this model, code level performance bugs are found so far at the end of the process that there's not enough time to fix them, so you let them leak into production, or even if you have found them, you might find that they leak into production, and then you have issues on your busy day, and you need to either go back to a previous version of your product or fix it immediately with a fire drill type of process. Also, different teams are working on these things. Sometimes you have your load and your performance experts, and you have your developers, and they're not working together. The load team might be busy with something else. And as a result, major issues are escaping out to production. And production is the most expensive place to fix a bug. The cost of fixing a bug in iteration 1, 2, at the beginning of your development cycle is so much lower than it is when a product has escaped out to delivery. And knowing that you've covered most of your bugs that early in the process is going to give you a whole lot better sleep, as you know that your application is not only functionally running well, but performance-wise running well too. If you throw continuous load testing in and measuring your performance on a regular basis, right from the very first iteration, as soon as you build your first line of your first new function, you can build a small performance test against that and compare, set a baseline for how that code is performing. If you're modifying a piece of code that already exists and has a performance baseline already, you can compare the results of how does that test perform, how does that code perform now with the new code modification versus the previous version of the code running. And with this way, you're able to get your performance testing done much earlier in the process at smaller loads where the cost is low and the results come back quickly, just like your unit tests, just like your functional tests, your BAT tests. If you're getting performance tests back that quickly, you're going to get results better. You're going to have those answers back to you, and you're going to be working on the same code that's being load tested and performance tested at the same time. So you're still in the context of how is my new code working? Is it working well? Did it get tested well? And is it performing well? And if it is, great, you move on to your next task. And if it's not, you can keep on working on it. Running these tests incrementally is going to give you, especially automatically, it's just going to give you a peace of mind that you know that your code is working well and your architecture is working well, and you find your database issues, you find your code issues, you find your performance issues so much faster. And then you let your performance team, those pros who are good at working on that large performance test, work on just the issues of the infrastructure and the deployment level of performance issues, where things can only be caught in production when they're being run on your production system at production load, where you might want to be testing with 100,000, 500,000, whatever the number of thousands of virtual users are, that will make sure that your test runs well at scale. And this will minimize production escapes, again, where the cost of getting those bugs out to production is so much higher, and reduce the time that you even need for production testing. Now, how that fits in, if you're doing CI already, you know that you've got your automation set up that as soon as your developer has made a code change, the change is detected by your workflow engine, hopefully Jenkins, and that causes a build to launch and some automation to start. The build is done, unit tests are run, some level of basic acceptance tests are run, some smoke tests, and then some level of functional test, and your performance test could be run right there also. And our tool is called CloudTest, and CloudTest is easy to connect into Jenkins. It's one of the many plugins that are available, and it lets you run your performance tests right as a part of your CI build. If you're doing daily and more frequent updates, this keeps you not only aware of the new functions, but aware of the performance of the new functions. And with the results that come back from the performance test, you can see the bottlenecks, inform the team, and just like unit and functional tests, these can stop the build from moving forward and you can send it back to the developer for modification and addressing the issue, the performance issue, just like a functional issue. So here's another poll question. We want to know what type of load testing you're doing today, if you are. Are you doing load testing against your non-web protocols, or mostly you have web protocols? Hopefully, if you've got mobile, you're doing some mobile web traffic too, web and mobile, or all of the above. Take 30 seconds to respond to the poll, and we'll see where people are in doing load testing. I guess we need another option for, we're letting our customers do the load testing for us, but hopefully that's not the, that wouldn't get a lot of responses. All right, about a couple seconds left. Oh wait, this one looks like it was possibly set for, there we go, the poll is ended.
All right. So we're looking at 11% for non-web protocols, 23% for primarily web protocols, 11% for E, which is all web, mobile, and non-web protocols, and 0% for both C and D.
0%, okay. That's great that most people have moved over to, that a good number of people have moved over to E, which is you're looking at all types of load testing. But it looks like that doesn't quite add up to 100%. So some of you, actually we don't have a none of the above option, which would probably capture that larger percentage. So it's great that you're here with us to be learning about this. And since many of you are already aware of CI and tools for continuous integration, you're here to learn about how performance fits into that path too. All right, well, now I'm going to hand over to Brian, my colleague from CloudBees, and he's going to talk about Jenkins and CI/CD opportunities there.
Thanks, Tom. That was a lot of great information. To everybody that has attended this webinar, thank you for giving me an opportunity to speak to you today. A little bit of background about myself. I'm currently a DevOps evangelist with CloudBees. I've spent 22+ years in software development in various domains. Most recently, I've focused on helping organizations optimize their dev, test, and operation processes and practices as a DevOps practitioner. So I'm going to build on what Tom has spoken about to talk about enabling continuous performance testing using a Jenkins orchestrated CI/CD pipeline. I'll start by covering some fundamentals around DevOps, continuous delivery, and at its core, continuous integration. I'll introduce you to Jenkins and the capabilities provided by Jenkins. And then I'll talk a bit about the value add that CloudBees offers on top of Jenkins. When I'm done, I'll go ahead and hand it back to Tom for a live demo. So, why are we here today? Well, fundamentally, both Tom and I, or SOASTA and CloudBees, are talking about delivering better software faster. And what I mean by that is getting to a place where we can go from concept to customer with high-quality software that delivers value to the end user rapidly while eliminating waste and enabling innovation in the marketplace. So, how do we deliver better software faster? Well, we need to look to connect the development of software to the delivery and operation of that software in a production environment in a way that we can deliver rapidly, repeatably, and reliably. And this involves moving from a place where there's a distance between dev and production and shifting production concerns to the left, such as going from performance and load testing being something that's done in production or just before production as a lead event to something that's being considered out throughout the development process. and then shifting our dev right so they're constantly maintaining awareness of production considerations such as performance. Ultimately, we want to have collaboration, close collaboration between development and production operations, or in other words, we want to achieve DevOps. Now, DevOps is probably a term that you guys are familiar with, but just to recap, DevOps is a software development philosophy or methodology that places an emphasis on communication, collaboration, and integration between the dev, test, operations, and other stakeholders in the software development process to ensure that all of the stakeholders are marching towards the goal of producing better software faster and getting that deployed to the customer so they can recognize value sooner. The issue with DevOps, though, is DevOps is not something that you can do. DevOps is a goal or an outcome. It's a state that you achieve through certain processes and practices. So if we want to deliver better software faster, and we want to do that via a DevOps philosophy, what can we do about it? Well, what you can do is continuous delivery. And it sounds like a major portion of the audience today is already practicing CI. Sounds like the minority of the audience here has managed to extend their CI process to continuous delivery. So we'll spend some time sort of recapping what is continuous delivery and how do you extend CI to a continuous delivery pipeline. In short, continuous delivery is the application of lean manufacturing principles to the software delivery cycle so that you're rapidly, repeatedly, and ultimately continuously delivering software from concept to customer. More frequently than the traditional quarterly or every 6 months, or rather you're increasing that frequency to multiple times a month, maybe multiple times a week, or like some rare organizations, you're delivering changes to the customer multiple times a day. So I also like to say, in saying you can't do DevOps, I tend to classify DevOps as the what. It's what we want to achieve our goal of quality software fast. But to get to the what, we have to build up the how we achieve DevOps. And we do that through various common processes and practices, such as establishing iterative development processes, then extending those iterative development processes so that within those iterations, we're continuously integrating. And then enhancing or extending our continuous integration such that we're continuously delivering, meaning we're always ensuring that with each iteration, we are generating and delivering production-ready software. So we're taking into account not only the feature domain, but the non-functional domain, such as performance, the functional domain, and the operational domain, such as being able to handle load. And we're increasing integration and automation from agile iterative development through to continuous integration to continuous delivery. So ultimately, we can reach a DevOps state where our collection of processes and practices establish CI and continuous delivery as the foundation of a DevOps transformation. I'm going to step back and talk a bit about why this idea of shifting performance testing and load testing to the left is so important. Is really we've moved into a state where the lines between continuous integration and continuous delivery are blurred. Originally, continuous integration tended to focus more on integrating changes at a source code level, ensuring as you integrated source code changes, your build didn't break. But with today's technologies, it's more a case of validating your change is more of a case of ensuring that API calls are compatible, that functional scenarios stand. And what this means is we need to shift to a place where we're bringing various services together in an integration test environment and validating runtime functionality, but we need to be able to do that as a non-event at a pace that supports the classic short CI build loop. So to repeat, the line between continuous integration and continuous delivery has blurred, and really if you're doing true and robust continuous integration, more often than not, you're embarking on a continuous delivery journey. I do like to mention that at the end of the day, the iterative agile processes we talk about, continuous integration and continuous delivery, are fundamentally about feedback. So gathering information that we produce during our development process and providing that information to all of the process participants so we can use that information to improve the product of the process. And as I said earlier, then increase value and eliminate waste. So, how do we do continuous delivery? Well, automation is key. Just as Toyota had done with lean manufacturing, you need to optimize and automate your software development pipeline just as you would an automotive assembly line. Continuous delivery is a process of applying that automation to your application development lifecycle such that you can rapidly and reliably move from dev through to committing code changes, building those code changes, executing quality scans and tests, staging and validating the functionality, and then ultimately being able to reliably deploy those changes out to your customer base in production. And throughout this cycle, your automation needs to enable the creation of that feedback loop from each of the life cycle phases back to the life cycle participants so they can make the necessary improvements. Now, CD starts with continuous integration, which is the process of automating your application build and test. And it sounds like nearly half of the audience here is familiar with CI, and they have implemented it. Hopefully they implemented it robustly so that it's not only a process of building and validating that your build works, but you're also doing validation, you're doing test, and hopefully even embarking on incremental performance tests, as Tom mentioned, and reporting those results back to the stakeholder. So, enter Jenkins into the picture. Jenkins has long held the position as the #1 automation engine used for continuous integration. But as we start to talk about this concept of shifting our production concerns like our performance tests to the left, it's important to note that Jenkins is also a key to your continuous delivery pipeline. So Jenkins can easily extend your CI process beyond simple validation and code scans to non-functional and functional testing, such as performance and load testing. So in case you're not familiar with Jenkins, Jenkins is an open source CI/CD server that acts as an automation engine for your SDLC or your CI/CD pipeline. It's about 8 years old. It's very easy to install. You can download Jenkins and get Jenkins running within a matter of minutes. It has a very large plugin ecosystem. There are over 1,000+ plugins that enable Jenkins to integrate with practically any tool or process in your pipeline. The fact that it's easy to install, that it supports such a large ecosystem, has resulted in wide and rapid adoption. Today, we have over 100,000+ installations of Jenkins in the market. So the Jenkins ecosystem, integrations and ecosystems are a key part to being able to enable you to automate and orchestrate a CI/CD pipeline such that you can rapidly go from development through to build, commit, and build to executing your test and ensuring that you have continuous quality and continuous performance in the software product that you're delivering. Jenkins ultimately becomes the hub of your CD ecosystem, allowing you to not only integrate with your SCM tools, but with a variety of build tools, and then enabling you to integrate with solutions like SOASTA's CloudTest so that you can facilitate your performance testing early in your CD pipeline. And then ultimately, as you validate that product and you ready it for production, you can rapidly deliver it to your customer. Another reason why it's important to consider Jenkins as you look into a transformation to continuous performance testing is that Jenkins is probably already existing in your organization today. What you'll often find is that there's a Jenkins installation and Jenkins knowledge and expertise that lives either in the development side of your house, of your organization, in QA, or in operations. And because there's already some expertise and a certain level of adoption, Jenkins is a great starting place for growing from continuous integration to CD, and then ultimately crossing the boundaries of dev, build, test, and operate such that you can achieve continuous delivery in DevOps. Now, I say you guys are probably using Jenkins today because if we look at a poll, a 2014 survey done by Rebel Labs, 70% of the respondents were using Jenkins to implement CI. So if you're interested in adopting Jenkins to help facilitate continuous performance testing, how do you do that at enterprise scale? Well, enter CloudBees. CloudBees is a company in which the Jenkins founder and still a major Jenkins, a member of the Jenkins governing board and a regular Jenkins committer is our CTO, Kusuke Kawaguchi, who we also call KK. And so we are well positioned to take Jenkins and enhance Jenkins for the enterprise so that it can operate at scale. CloudBees Jenkins offerings include both private and public offerings. In way of private offerings, we offer CloudBees Jenkins Operations Center, which allows you to manage a Jenkins ecosystem at scale. And we offer CloudBees Jenkins Enterprise Edition, which gives you key enterprise features for establishing and managing your CD pipelines at scale. We also offer a cloud-based or public-based instance of Jenkins Enterprise, which allows you to quickly adopt Jenkins and allow you to rapidly and elastically scale it as needed. Actually, when Tom does a demo, Tom will be doing a demo in our Dev at Cloud Jenkins instance, so you'll get a chance to see how our public implementation of Jenkins in the cloud functions. We also provide support and other Jenkins services, such as professional services, training, security advisories, and communications of key information to the Jenkins community and from the Jenkins community to our CloudBees customers. So specifically, how can CloudBees Jenkins Enterprise help you with your CD strategy? Well, there's a number of things, but to cover a few key points, CloudBees delivers enhanced Jenkins workflow to provide a way to define flexible delivery pipelines and enable you to manage and share performance testing as code. In addition, CloudBees offers workflow visualization, which gives you deep insight into the execution of your workflow stages so you can quickly detect problems and performance issues, and enabling you to manage complex level of detail testing pipelines, such as moving from incremental performance tests within iterations to, in parallel, being able to do your larger performance tests prior to deployment to production. CloudBees enables dynamic environment creation, so you can quickly spin up, build, and test environments automatically as part of your delivery pipeline. We enable you to track and verify your deployments. And then we offer analytics that allow you to monitor and analyze performance across all your Jenkins deployments, and establish metrics that enable you to monitor, measure, and manage adoption of best practices for testing, CI, and CD. Ultimately, Jenkins is the hub of a CD ecosystem, helps you enable CI, CD, and continuous performance testing as a central source of orchestration to bridge your dev, test, and operations domains together. So we'll quickly take a look at some visual examples of some of these features. Jenkins workflow and workflow stage view give you a way to flexibly establish complex delivery pipelines, build those pipelines in stages so you can easily manage extending from just CI and building to supporting quality analysis and performance tests, to doing automated functional QA, to staging of your software product for manual test and UAT. You can track your success at each of these stages, and you can track your progress of your software deliverable through each of these stages. CloudBees Jenkins workflow also enables you to manage long-running tests, such as your large performance tests, in a way that if those tests fail, you can establish checkpoints so you can restart those tests without having to go all the way back and re-execute prior long-running tests. So it makes it more economical for you to include more comprehensive testing as part of your CD pipeline. In addition, you have the monitoring, visualization, and analytics that allow you to look across your build jobs and across your teams to manage and maintain not only your Jenkins performance, but also adoption of your CI and CD practices. Jenkins also enables you to test at scale through the use of cloud support or leveraging Docker containers so that you can manage your testing infrastructure in a similar way to managing your code. So you establish your testing infrastructure early in the pipeline, and then you can deliver your testing infrastructure along with your managed code and your managed tests. In addition to the services we covered, we also provide Jenkins certified training, Jenkins consulting, Jenkins newsletters, and Jenkins users conferences to enable our CloudBees customers and Jenkins users to learn from other community members. So Tom, with that, I think I'm ready to hand it back to you so you could show us CloudTest and Jenkins working together.
All right, thank you, Brian. Now let me just go ahead and see if I can take control. Actually, Brian, why don't you pass the ball to me for screen sharing? Great. And now I'll share my screen and give you guys a look at some of how to put this into practice. Now, what I've got here running is CloudTest, which is our performance testing tool. It runs from the cloud, or it can run in your own instance behind your firewall. And what we're going to show here is, actually I went away from the slides too quickly, there's a JBoss sample web app called Ticket Monster. And Ticket Monster is just a simple application that lets you run what looks like a ticket purchasing site for an event. So say like a baseball game coming up. And this is a type of application which, if it were your application, would definitely need to be tested for performance. You want somebody, when they're buying one ticket way in advance, to have great performance, and you want somebody when they're buying 1,000 tickets the moment they go on sale, or 10,000 tickets, like the Super Bowl's coming up, and everybody, 60,000 people are going to be wanting to buy tickets for that all at the same time. And for events like that, you really don't want your site going down. So whether it's Black Friday or a special event, you need to know that your application is performing well, especially if you have competitors. If you're in the retail space or other spaces, people will quickly abandon your site or your application and move over to your competitors if your performance isn't good. So what I've set up inside of CloudTest is 2 separate tests, one of the Ticket Monster site as a web application, the second as a API call, which they do have a RESTful API available. And then the third, we've also built the Ticket Monster mobile app, and we're going to do a functional test of that, but we also get some performance test information back from that. The difference in CloudTest versus other load and performance testing tools is that we build our tests visually. So here I've got a test already built up called Make a Reservation, and the Make a Reservation test is going to do some things like look at the events that are available on the Ticket Monster site, select an event, it's going to pick a venue and time, and then it's going to try and purchase that ticket. So this is a visual test. There's no code that's associated with this test. This is the test right here, and you see it's just using simple constructs like you could do in a high-level programming language, but we do it visually, like an if then else. We have delays in here so that this load test does act just like a real user would. Real users don't, well, they can work pretty quickly, especially when they're in a rush, but in general, they can't run quite as fast as a computer can, and you wouldn't want your test to overload your server in a way that doesn't model what real users are doing in your application. So this is a test that we've already automated. When I hit play, the test will start, and this is just going to show how many users. I've set it up to run with a maximum of 5 virtual users at a time, and it's going to load up to that. These are the results from the previous one, but you see how during a test we will bring the load up to a certain number of users, and we can then see how their results are coming across by different data that you'd want to be monitoring, how much data is being sent back and forth in the application, and how many users are being executed now, how many total executions are there. In the 1-minute test that I ran a little while ago, we ended up running the test 37 times across the 5 simultaneous virtual users, and we can see how the response time is affected by how many users are running at the same time. This was just a load test of only 5 users, so we actually didn't cause any errors to happen during the test, but we can do that when we want to stress the application and run a stress test. We can start raising that number higher and higher. The great thing about CloudTest is it can generate load directly from the server it's running on up to 100 users, or it can start to access cloud provider partners such as AWS or Google or GoGrid or Rackspace, or any place where you would have either a cloud provider account or you'd have a desire for their locations to be generating load against your site. These would then mimic the real users accessing your site and would be able to show your application being able to perform with larger and larger numbers of simultaneous users. So this automated test that runs, it runs pretty quickly in just a moment, in 1 minute, and you see the data that comes back. Similarly, if we were to run an API test, we would want to be able to test the API and see what the results look like for that. The tests are this is going to be a quick test that'll run. It's running simultaneously also with 5 virtual users. and against the API version of this, and we're going to look at what the performance looks like for that. Now this is great for the first step of any test automation is automating a test and being able to run it manually, and that's what we're doing here. We also have tools for being able to debug a test. Likewise, I've built, while that's running, I can take a look at, we have a mobile application test version, and similarly to the same interface as we had for load testing, we have an interface that a visual test editor that lets me build a test of clicks on different items. This was actually recorded directly from the application itself, the Ticketmonster mobile application, which I have running over here. Here, just similarly to the way that you can have load from the cloud, you can also have devices in the cloud, so that if you wanted to run a load test against multiple devices, you can allocate them from a cloud partner provider like ours here, which is NTT Resident. They have a project called AppKit, and it lets you access up to their pool of 300 plus devices of iOS and Android variants. I've connected up to this device, and if I run a test here inside of this application, inside of our touch test application, you will see that the test will run over in the device. And the device happens to be not on my desktop, not in my lab, but the device is actually over in Japan. That's where their lab of devices is. So even thousands of miles away, I can be running a test against a device, similarly to running a load test from thousands of miles away from my application. I might want to run from US East, US West, maybe I have some South American customers that I'm expecting to come to my site, so I'd want to set up some load to run from all of these different locations. So these are just some of the capabilities of CloudTest and TouchTest, the products from SOASTA. But when we look at automating these, now that we have the tests automated for execution, with a simple use of Jenkins, here I am now running in Jenkins in the CloudBees cloud. I have some jobs set up for running these tests connected up to the CloudTest and TouchTest servers. For example, the Ticketmonster make reservation task. I can bring that up. We see that I've already been running it quite a few times as a part of my CI system. It's pretty easy to set this up. This is a job that is triggered by, could be triggered by a build, or it could be triggered just to run over time. This build could be different options like grab the source code for it before we build it, trigger when either an external script is run, trigger it when something else is built, or just build it periodically. Maybe we want to do load testing on a regular basis on a schedule. And then for actually executing the test, we can use the SOASTA plugin for Jenkins, which lets us pick a server to run the test and pick the composition, the test script to be run, and get some results back. So instead of just running the test and seeing did the test run, I can actually ask the server to give back some data about the test run. Say, how long was the average response time for making a reservation? What was the performance at the 90th percentile? So the slowest 10% looking at that point. And what is the maximum response time across the whole test script? And this data will be pulled from the CloudTest server and brought over to Jenkins so that we can look at this data both graphically and as a part of continuing or not continuing the CI process. Similarly, if a functional test fails, you might want to stop the test and send it back to your developer and let them know that something didn't work. We can just click the Build Now button, which will cause the test to start over in the server. It's going to allocate an executor, and that executor is going to then talk to CloudTest and tell CloudTest to run that. While that's looking at that, I'm going to go ahead and look at the previous results just to see. Here was the build I ran earlier this morning, and if we look at the test results, we can click through and eventually get through to the CloudTest server by connecting through. And we see that this result that I ran earlier was all green, meaning that this process would be good for sending on to production. All of the results here were within the thresholds that I had set in the job, and that's great. So that lets us know, hey, this is great. We can move it on to deployment. Maybe that's going to be completely automated, or maybe there might be a manual check just to see before we send it back. If I go back to the back to the dashboard to see that the job is still running. Similar for running a functional test in TouchTest. It's very easy to set up a job here too. You just configure it. We have the plugin for CloudTest also, which runs TouchTest. And here we don't have any. I don't have any deep data to come back, but because this is a functional test. But I will want to track, is the test taking longer to run than it normally takes, so that I can see, is the test, if the test is starting to take longer, that's a performance metric that says something's wrong with my application, and I might want to not let that application go out to the App Store, because I might want to take a look at why is the test taking longer to run. All the results do come back, and you see when they do come back red, that is the chance for your automation to stop if needed. Results come back either as blue for good, red for bad, or yellow for unstable, which would mean you'd want to take a look at the output. And this is a very easy automation to set up, connecting between CloudTest and TouchTest and Jenkins. It's something that just a couple of plugins out of the CloudBees repository will give you these results. The data that does come back from the results is also graphable with the plot plugin, so I can see how are my test results coming back over time and see that they're still staying below the threshold of 13,000 milliseconds, 13 seconds, and I'm having some runs that are doing well, other runs that are taking a little bit longer, and again, but they're all staying within the threshold, so they're not going to stop the build, but I could look at and see what was different in each of these builds and see it looks like the developer is doing a good job of speeding up the code. These later builds are coming in faster than the earlier builds were doing. So that was a quick look at the demonstration of how to integrate CloudBees, Jenkins, and SOASTA's TouchTest and CloudTest tools for doing your performance testing automatically with every build, and for doing them as part of your CI and CD process. I'm going to go ahead and stop sharing my screen, and we can go back to slides and finish out the deck. So let me bring up the participants and hand this back to Brian.
Okay, thanks, Tom. And as I bring up the slide deck, I'd like to highlight how really simple it was for Tom to extend a powerful solution like CloudTest into a CD pipeline via Jenkins. And then with Jenkins, once you've made that simple connection, you're then enabled to leverage the power of the rest of the Jenkins ecosystem and support for things like workflow and cloud and containers to create a very rich, robust CD pipeline.
Just a quick line about a summary of the SOASTA platform. We do have the tools for doing the functional testing that I showed with TouchTest, for doing monitoring. We have a product called Impulse, and we have CloudTest, which will let you see how your product is, how your code is doing at production scale in performance. And again, our Jenkins plugin is available. It is an open source plugin, and it's available directly in the CloudBees plugin ecosystem. It's easy to install. It's just search for SOASTA, and it gives you complete control over CloudTest and TouchTest with the ability to measure against thresholds and set threshold barriers for when should the CI process stop.
Excellent. Yeah, thanks, Tom. And I think I'll also note that if you guys are interested in discovering more about the capabilities of SOASTA CloudTest and CloudBees Jenkins, you literally can spin up a Jenkins instance in DevEt Cloud with the SOASTA plugin in 10 minutes and be up and running, beginning to connect your performance testing to Jenkins. So at this time, I think we managed to slide in with about 5 minutes to spare for questions. So if you can go ahead and ask any questions that you may have in the QA window of WebEx, we will do our best to answer.
I see one that came in that's asking about the plot plugin. That's another open source plugin that you saw me bring up some graphs that show the plotting against the different results. That's an easy one to set up. When the plot plugin is installed, you get an extra checkbox that asks, do you want to save your test results as a CSV for the plot plugin? And then the plot plugin asks, what is that CSV file and how to plot the data inside of it, whether you want to look just for a specific row or column, or whether you want to display everything and across how many builds, and it will save that data and display it so that you can see graphically how are your tests doing, more than just did the test pass or fail, as you might see from the job code, the job result. This gives you actual data about how the results were running. It's another free plugin that's great.
Excellent. Okay, I see we've actually got a good number of questions coming in the QA panel. Tom, are you able to see the questions that have shown up?
I see I'm looking in the chat panel where I see another one was just sent over that says, if your app server is inside your company firewall, can you still run CloudTest? That's one of the great things about CloudTest. It can run from the cloud. The instance I was running from the AWS infrastructure, being connected to from the CloudBees cloud, but it can run locally on your own server. It can even you can even download a light copy that runs right on a Mac or a PC and can generate load right from your desktop platform, or it can run inside of an ESX server, or you can just download it and put it inside of a Linux box and generate load within your company up to as much as your servers can handle. And great for pre-prod, great for just doing tests right at check-in, where you don't need the whole cloud universe of load generators banging on your application. You just want to do those 5 or 10, or even increasing it to larger numbers to see how the performance is as the volume is increased. Yes, you can definitely run it within your firewall.
Okay. Also in the QA panel here, I see a couple of CloudBees related questions. So one is, you showed a pipeline. Can you clarify which parts require the CloudBees solution versus the Jenkins solution, the standard Jenkins solution? Well, to clarify, what we showed you is I showed you the application of Jenkins workflow, which we also call pipeline as code, and then the visualization of that Jenkins workflow. So Jenkins workflow or pipeline as code is a CloudBees created open source contribution, so that's available in standard Jenkins. What CloudBees provides is extra visualization capabilities, so you can quickly get a high-level picture of how your pipeline is executing and the progress of your changes through that pipeline. So another CloudBees question in the QA panel is, what is that Dev at Cloud? Dev at Cloud can be found at developer.cloudbees.com, and we'll give you links at the end of the session. And what that is that's our public cloud-based implementation of Jenkins, which allows you to stand up a Jenkins master and Jenkins slaves with a couple of points and clicks of buttons. So we are starting to push time. Max, should we continue to take a few more questions, or how you want to handle it from here?
If there's one you can do quickly, great. Either way, I will be taking all these questions so that we can have them all answered and sent to you with the recording and slides either tomorrow or maybe Monday or Tuesday.
Okay. So one of the questions for you, Tom, here is, does CloudTest allow SOA testing, i.e. testing web services with SOAP over HTTP/JMS?
That's a great question. Yes, I did show testing against the web API or HTTP protocols and also against a REST API. It also does direct-to-database testing, SOAP testing, and WebSocket testing. And we're actually very responsive to customers as new technologies are invented and our customers let us know that they would really like to be doing load testing against something else, we're able to pretty quickly build them in because of the way that we built this product. As soon as we can build something that will bang against that new protocol, then we can generate load against it. So yes, we do that.
Okay, great. So I think we can conclude our questions there. As Max said, we will capture these questions and then we'll work to answer them offline and follow up.
All right.
As next steps.
Oh, there you go.
Oh, excuse me, over to you, Matt.
I was just going to say goodbyes, but if you want to say anything about this first, by all means.
Yeah, just as next steps, there are some resources that you can leverage to learn more about SOASTA, including a link to download CloudTest Lite, access to white papers, webinar recordings, and case studies in the Knowledge Center. You can contact SOASTA via www.soasta.com/cloudtest or info@soasta.com. For CloudBees, you can actually try our Dev@Cloud Jenkins instance with a SOASTA plugin at developer.cloudbees.com. There's additional documentation on the CloudBees Jenkins platform that will be provided with these slides, as well as more information on workflow and orchestrating your CD pipeline with that. And I also encourage you to take a look at the white papers that will be linked in the slide deck. You can get more information from CloudBees at info@cloudbees.com.
All right. Thank you, everyone, and we'll be in touch.
Thanks, everyone.
All right. Thank you. Bye-bye.